Good morning, guys. I hope you're doing well. So we're getting ready to talk about our first experiment that is not a virtual experiment. This is the experiment 4. So this is going to be a little bit different than what we talked about before. Hopefully you'll be able to follow along with what we're talking about. When we talk about experiment 4 is related to the solubility product constant. So we're going to walk through a little bit of the information that needs to go with this. Now, when we talk about the solubility product constant, we're going to be going to assignments, and I'm in here in the student view. So I'm in assignments. We're going to be looking at solubility titrations. You'll see that there are a number of things that are in here for this. So one is the summary, which has experiment 4 with data. You'll have the lab manual, the data, so that goes with this, and then the post lab. So I'm going to click on the lab manual first. Now, obviously, this goes with solubility titrations. So the expectation is that you have looked at the content that goes with this first. So if you haven't gone to the content, we'll go there first. And this is related to exam 1 and titrations. So this is related to the solubility titrations, and actually that's under precipitation reactions. So this is about precipitation reactions. And so this is related to the material underneath the lecture 5, precipitations. So you should have not only looked at this PowerPoint, but also watched the precipitation video that goes with this material. So if you have any questions about this will talk about the precipitations video and the molecular ionic and anionic equations and all of the wonderful stuff that goes with this solubility equilibria, practice with writing KSP expressions, and the solubility rules that go with this. And we'll be talking about all of the how we know whether this is a soluble product, how we write the KSP expressions, all of the stuff that goes with this. So this lab is related to these solubility relationships. Now, in terms of the lab, again, go back to the assignments, and we'll be looking at this material. So the lab manual talks about this. And this is from the lab manual that we used to use for this for the in-person class. We still actually do use it when we're in an in-person class. And this is experiment 4. And so this talks about the molarity, being moles per liter. I'll let you read most of this. And we're looking at this relationship for silver acetate and the KSP for the relationship between silver and the acetate ion, of course, that being in moles per liter. And we're looking at how we write an ice table for this, and of course, the solid being very large comparative to the concentration of either the ions that are with this. And we're looking at the concentration for, and either of these guys being related to what we're putting into this, okay? And we're looking at what happens when we have the presence of this ion from any other particular location. So we are looking at common ion effects for this. We are looking at what happens when we have this from other locations, what happens when we have this from different places. So we're looking at the effect of this solubility from several locations, from just solubility from one location, not a common ion from multiple locations. So we're looking at it from just silver acetate and water, from silver acetate in the presence of KNO3, in the presence of AgNO3, and from the presence of sodium acetate. Okay, so we have all of those things in combination. looking to see what effect does those common ions have on that solubility constant. Okay, so that's the effect that we're looking at. This is why there isn't a really good counter to this in anything else, because we aren't looking at all of the same effects. Okay, so we have different solutions that we're looking at in looking at these particular scenarios in looking at this. So we actually have 4 different titrations that are going on. One where we have just the AgNO3 or AgC2H3O2. Okay, when we have the AgC2H3O2 with the KNO3, one with the AgC2H3O2 in AgNO3, one with the AgC2H3O2 in NaC2H3O2. So common ion for those. So we did titrations with all of these, and then we look at the data that we get from that. And then there's a table that walks you through how we do those calculations based on the scenario that we're looking at. So this is a complicated table. It walks you through how we do those calculations, all right? And so it's supposed to help you to understand how those calculations are done. So this is the information from the lab manual about how these calculations are done. So that's the information from the lab manual. Now, in addition to that, now you get this data. So this is the set of data that comes from this experiment. So if you were a student in the physical lab and you weren't able to actually do this experiment, this is the data that you would get. And what this tells you is that for each of these solutions, this is how much of solution A you would be running with these things. So you would run a solution, this is how much of the titrant you would have put in for the 3 replicates of this solution. Okay, so how much of that titrate you would have put in for 3 replicants of that particular titration to get to that endpoint. So as it states in the lab manual that you've done this titration. So we did each of these titrations, and we did a solution of saturated Ag C2H3O2, and in our beaker we had our 0.05 molar KCl, and then we had our solution of saturated AgC2H3O2 in water. That's our material that's in the burette, and we added in the first titrant 5.3 milliliters of that solution to the 0.05 molar KCl in the beaker to get that to the endpoint of that titration. Okay, so that's how much we added. So we need to know, based on that amount, how much of the Ag was in that beaker. And that's based on the amount that we added. Okay. So that's what we're going to go through in that calculation, is to look at, based on the concentration that we added, that N1 that we added to that, the number of moles, we'll divide by that volume to figure out how much of that Ag we had. So that's what we're going to be calculating. We're going to do that in triplicate and then find an average for that to get us the amount that we need. Okay? So that's what we're going to be doing for each of these. So those are the calculations that we're going to be looking at. Do that for each of these solutions. So solution A, solution B, solution C, and solution D. So that's what we're going to be doing for our calculations based on the numbers that we've been given for these. Okay. So that's the assignment that you have. This is the data that you've been given, and those are the calculations that you're going to do based on the information in this table. Okay. Now, once you've done that and you've worked with this data, then you have our This is the pre-lab that you would have been given. So this is the pre-lab experiment that you're supposed to do. This is the lab summary. So this is, you're supposed to fill in this lab summary. So, right, the objective, your molecular reaction completed from so what were the reactions that you did with the 3 titrations based on what you read in the lab, right? The dissociation reaction for the solid silver acetate, okay, which was looked at in solutions A through D, right? The KSP expression for the silver acetate. Show me an example of all your calculations, okay? And show me how you do this calculation. So if your moles of Ag plus equals your moles of CO minus, so what's the molarity of the silver ion in solution D? So walk me through all of your calculations. Then you're supposed to look up the KSP for AgC2H3O2 from a reliable source. Just tell me what your source is. I don't care what your source is. Just tell me what your source was. Wikipedia is fine as long as you source it. Okay, that is okay. Other things you can look up source-wise, your textbook is an excellent source. Alex is a perfectly fine source. Things like that are fine. Okay. Your discussion and reflection, the value of KSP was calculated for 4 saturated solutions of silver acetate. So you're going to do this for the 4 solutions, your A, B, C, and D. Did they agree? If they didn't, explain why they might not be different or why they might not be the same. So why might they be different? Talk to me about why. Okay. Provide the 2 specific errors that were applicable in this experiment. So I know you didn't actually do this experiment, but why might there be errors? What are things that you can look at in this procedure that might be errors? And it's okay to be critical of the experiment as written. That's perfectly fine. These experiments were written by a person. They may not be the best experiments in the world. It's okay to be critical of them. Talk about Le Chatelier's principle. Explain what happened to the solubility of the silver acetate in solution C and D. So talk to me about what might be going on there. And what role did the potassium chromate play in these titrations? Explains in terms of solubility and Le Chatelier's principle. Okay. So I want plausible reasons for what might be going on there. Give it some thought. Why might those be going on? So some ideas of what might be going on there. Okay, so that's what the summary is for. In terms of the post-lab, your post-lab, you need to answer these questions. These are similar to the post-labs that you've done for other laboratories. So similar to what we've done in Alex. I'm just going to have you write these out and submit this all to the assignments. Okay. So why is it necessary to know the correct formula for a salt in order to write the ion product constant expression? If a common ion is added to a saturated solution, does the KSP change? Does the solubility change? Explain. Consider a saturated solution of silver chromate. Write the dissociation reaction. Write the ion product constant expression KSP in the box. Calculate the molar solubility of silver chromate in water at 25 degrees C. Show your work. KSP equals 1.2 times 10 to the minus 12. Calculate the molar solubility of silver chromate in 0.5 molar solution of potassium chromate, K2CrO4. Remember, the units are moles per liter, not moles, not M for solubility. Compare the solubility determined above. Did it increase or decrease? Explain in context of equilibrium reaction any shifts that occurred. Okay, so you're going to answer these questions. Again, this is very similar to what you would be doing in Alex, but I just want you to write them out and then take a picture of what you've written out and turn these in. So you can print these out, write all over it, and then turn it in. So this is no different than what we would typically be doing, but I want you to write these out and turn them. So this is what we call a dry lab. So instead of actually doing the experiment, you're just doing this on paper and then turning in your data. That's it. So this is what we call dry labbing. So you're taking someone else's data and performing the experiment as if you had done it yourself. So you should have everything you need between the lab itself, so this lab and the instructions, the data that you've been given, the summary, this here, and then the post lab. You should have everything you need to be able to do this. If you have any questions, comments, problems, anything at all, ask me. Okay? I'm more than happy to walk you through anything you need to do for this. It should not be a big deal. You should be able to walk through any of these calculations without much of a problem given the information that you have. But if you run into any problems, anything at all, then please let me know. You should be able to manage this, but if you have any problems, let me know. Okay, so that's everything that you need to be able to do this particular experiment. Okay, again, I don't anticipate any particular problems with this, but again, if you run into any issues, let me know. Just make sure that you get this work done before you need to turn it in, and you should be fine. Okay, if you want to work with other people, that is fine. I have no issue with that. You can talk to each other, do whatever you need to do. Just make sure you get some experience in working with these numbers. Okay, so have fun with this. Do with it what you can. It is a little bit of a a bit of a terror to work with the common ions, but it shouldn't be that much of an issue. Okay, all right. Have fun. I will talk to you guys later. Let me know if you need anything. Thanks.